Hi, everyone. Welcome to the meetup on October 12th. And I'll introduce Michael Scribner, APMM's president.
Thank you, Sam. All right, so most of us have used Waterjet cut parts at some point in our careers. Problem with them usually is, for a lot of us, especially ones with smaller model shops and the like, the parts can be, fairly small parts that we need. And well, as far as considering buying a piece of equipment like a Waterjet, they tend to be really big, really expensive, really maintenance intensive. So it can be a challenge for some of us with the smaller shops and the like. We'd like the flexibility of the machine that can cut anything. And that's kind of, more or less what the Waterjet, promises. Well, our guest today has a unique solution to that problem, the small format Waterjet. So I will go ahead and introduce to you the team from WAZER. And that Tom Hurd, the VP of Sales, will be giving us a demo today. He'll be showing us the machine in action. He'll be showing us some samples cut from it, and they'll be answering some questions for us. There's also a couple other members from the team over at WAZER there, and I'll shout them out real quick. It was Chris Cardinal and Dan Cohn. If you have any questions, you're welcome to type them into the chat, and those two will, give us some answers while Tom's doing the demos and the like. So without any further rambling from me, I will hand this over to Tom and let him take it from here. Thank you, guys.
Thank you very much, Michael. That was a nice introduction. Thank you. Yeah, we look forward to demonstrating the WAZER for you today. What we've got planned for you is the standard demo we do, and we do a lot of them, is to show you how it's installed, how you start a cut, and then how you create the G-code files by sharing my screen. But we want to really particularly emphasize for this group the versatility of the machine. So we've prepared a multi-material cut. Chris, our in-house model maker, created this little model of a house. It's got a front and back wall, 2 side walls, and a roof. And we're going to cut all those pieces out of different materials for you today, just to show the versatility. And then, of course, it fits together quite nicely and snaps together. So we have prepared the cut bed with those multiple materials. It's unlikely you would cut it like that in real life, in real time. You would cut multiples of the same material probably at a time, but we wanted to try and capture as much of the versatility of the machine as possible in this short demonstration time. So with that said, I think I'll just get started. I'll transfer to the handheld camera. I'll try my best not to make you all nauseous as I'm moving the camera around, and show you how we have the WAZER installed and how we start a cut. And then while it's cutting, each cut takes a few minutes. While it's cutting, I'll switch to sharing my screen and demonstrate the software. Okay, just put any questions in the chat you like, and either Chris and Dan will answer them, or we can get to them at the end, whatever works for everyone. So the machine here in our demo room is the stand-up version. Hopefully the camera will focus in a second. There we go. So this is our stand-up version. Down at the bottom there, you can see the pump box. The pump box is where the high pressure is generated, and the pump box is connected to a water inlet. So these pipes along the wall, these 2 plastic tubes, PEX tubes coming along the wall, one is the inlet to the pump box, and it requires about 1 gallon a minute of flow minimum and 35 psi. The other pipe you see on the wall is the drain from the main unit. So you've got 1 water supply coming in and 1 tube coming out, going down the drain to drain the used water. So it does need to be connected to a water supply, a supply line. The pump box uses 110 volts and about 15 amps. So you see we've got it plugged in the wall there. The main unit and the pump box have their own power supplies. The main unit uses 110 and about 5 amps. So if you have a 20 amp circuit, as we do here, you can plug both into the same same 20 amp circuit, 110 volt, 20 amp circuit. So if we just get a little closer to the machine, I'll show you where we put the abrasive. So the machine runs on cuts with abrasive and water pressure. So the abrasive comes in these either in these buckets or on a pallet. You can see it's just garnet abrasive, the same crushed garnet, 80 mesh crushed garnet abrasives that all water jets use. So we just pour it in through these screens here to prevent any clumps. And this is the how we fill the dry abrasive hopper. You can close that. When that's full, you've got about 1 hour of cutting time with a full hopper of abrasive. Holds about 20 pounds. So you can open it and add more during a cut. It will not interrupt the cut. And it will also warn you after about 45 minutes that it's been running for 45 minutes. You need to refill the abrasive. There are some safety features on the door. On each end of the door, there are sensors. They both control the high pressure system or parts of the high pressure system. One controls power to the high pressure valve and will not allow it to open. And the other controls power to the high pressure pump. So there's two safety features to prevent the high pressure coming on if the door is open. Just zoom in a little on what we've got set up here. So the tank is full of water, as you can see. That's the first thing you do when you set up your WAZER is you fill your tank full of water. After you fill it, there are sensors in the back, three sensors in the back that control that water level. So you never have to worry about it again once you've filled it up. There's a low level kill sensor that will not allow that warn you that it needs to have water added. But it won't allow it to run if the water is too low because we don't want the water pressure piercing the bottom of the tank. You've got to have a full tank of water. There's a high level kill switch, which will also prevent overflow. If the optimum level sensor was ever to fail, we don't want it to just keep filling up and overflow. So there's a high level kill, a mid-level optimum that turns on the drain pump when that is triggered, and then a low level that again kills the power if there's not enough water. So those are all part of the CE and UL certification. The cup bed, just take note of this grid pattern on the cup bed. So the cup bed is made of this corrugated sheets of plastic. So we've got holes in it that allows the water jet to pass through, but it also allows for easy installation of the material that you're going to cut. And what we use is just these standard stainless steel pan head wood screws. They just screw right into the cup bed, and the head of the screw holds down the material like this. So here we've got a piece of carbon fiber, piece of aluminum, and you can see the screws that we've got in the cup bed. And then we use this grid pattern. Each one of these squares is a 3-inch square. So you see you've got 6 squares across and 3 squares up and down. So 18 inches by 12 inches, but you've got a little more than that. So you can actually cut 12 by 18 inches. The gantry travel is a full 12 by 18. So we give you a little more on the cut bed so you can put a full 12 by 18 piece in and still hold it down with the screws. So there is a used abrasive collect cycle in the firmware to collect the used abrasive. So when it's running, you're pumping water at about a half a gallon a minute into the tank, and you're mixing it with dry abrasive. So the high pressure water comes in the top of the nozzle here, gets focused through a jewel orifice, comes down, enters the mixing chamber here, and the action of that stream passing through the mixing chamber creates a vacuum in this dry abrasive tube here. So this is the dry abrasive tube that connects to that dry abrasive hopper that I was showing you. So the water and abrasive gets mixed in here, comes out the end of this. Under this plastic cover here, there's a tungsten carbide nozzle tip. So when it's running, when it's cutting, you're pumping water and abrasive into the tank. So the water level will start to rise. The optimum water level sensor will trip and it will turn on the drain pump. The drain is pumped. It's not a gravity drain or anything like that. It is actually pumped at about a gallon and a half a minute. And it's well filtered so that the dry abrasive, or now wet abrasive, stays in the tank and collects in the bottom of the tank. And we have a used abrasive collect cycle. It's the only water jet that has this, where it runs some low pressure pumps in the bottom of the tank and circulates the water, and it pumps highly water that's got a lot of abrasive in it into the front here. So I'll just run that for you while we're talking about it. So the low pressure pumps in the bottom of the tank basically circulate the water, and you can see here that's heavily loaded with abrasive. On this side also heavily loaded with abrasive. They dry it, and the abrasive collects in these two buckets at the front, and then you just lift them up and empty them out. And at that point, it's just wet sand, so you can just dispose of it as you like. So the only adjustment on the WAZER, there's only one adjustment on the WAZER that you have to make, and that's the Z height of the nozzle relative to the material that you're cutting. So the distance from the top surface of your material to the tip of the nozzle is an important setting. And the way we control that is we provide this little gauge on top here. It's got a tab on it. So you lay that down on your material, turn the knob, raise the nozzle, lay that down under the nozzle, bring the nozzle down onto that tab, tighten the knob, and that's you set your nozzle height. So the Z position of the nozzle, or the nozzle height relative to the material, is now set. Just put your cap back on top, and that's how we set the Z position. So we'll close the door now, and we'll try and start a cut. So just to explain what we're doing here, we already cut two of the pieces for the project that we're going to cut for you today. So it's this little house here. So we've got multiple materials. We've got acrylic, we've got glass, carbon fiber, high density polyethylene, and aluminum. So we're going to cut these 5 pieces out for you during the cut, and just so that we could fit it all in the same in the demo time, a reasonable demo time. We've already cut the carbon fiber and the aluminum piece out. So I'm going to cut the high density polyethylene, the acrylic, and the glass piece. So I'm going to start 3 cuts during the demo, because these are 3 separate G-code files, 3 separate cut files, because obviously it travels at a different speed based on the material that you're cutting. So they are different cut files. But we wanted to set it up this way to show you the versatility of the machine, the number of materials it can cut, etc. So just to explain why it's set up that way, normally what you would do in normal circumstances, you would be cutting one material with multiple parts in it or something like that. So let me try and show you the screen here. The files, the G-code files that we create, and I'll show you how we do that in a minute, are fed into the WAZER on an SD card. So the WAZER itself is not connected to any, it's not connected to Wi-Fi, it's not connected to Bluetooth, it doesn't have any of that. It gets all its information from the SD card. So the main menu is select cut file or setup and maintenance. If we go into the maintenance, you can see there's that used abrasive select. You can do a nozzle purge, a tank cleaning, all those maintenance cycles are in that menu. What we're going to do today is we're going to select the cut file. So when I choose select cut file, it goes in and it reads the SD card. So I'm going to choose the first file we're going to cut, which is the HDPE file. And I'm going to tell it I want to cut that file. So the first thing it does, it asks me, do you want to prepare the machine? I'm going to say yes. So it warns me to make sure the nozzle is clear, which I've already checked that. But the reason it does that is this is where it calibrates. So when I click OK, it basically goes to 0, 0 up in the top left-hand corner, calibrates itself to 0, 0, and then comes back to where that cut file, that G-code file, is telling it to start this cut. So then it just walks me through a couple of reminders. Have you filled the abrasive? Have you turned the water on? Have you fastened the material? Have you set the nozzle height? Now, this option, just before I start the cut, it's going to ask me or give me the option to actually start the cut. I could do a dry run of the cut. I could do check the cut extents, or I can move that origin. If I don't think I'm positioned correctly where I want to start my cut, I haven't positioned my material in the right spot on the cut bed, I can move the origin of the cut. So let's just do a check cut extents where it just runs through all the way around the perimeter of the cut, just to make sure. I'll just show you how that works. So I'm just checking to make sure my cut extents are all on my material, which they are. So now I'm going to start the cut. And when I start the cut, you'll see it'll go to the first pierce point and it'll start piercing. And when that splashing on top of the material changes, that's when you know it's pierced through. That's it pierced through, and now it's going to start the cut. I'll just let you watch that cut just for a minute. I think it's going to cut a little hole. So you see the turbulence in the water around the cut bed, and even coming up through some parts of the cut bed. That's why you need to make sure you've got your material fastened down. There is no force during the cut that's trying to move the material left or right, north or south, east or west. All of the force is that turbulent water trying to lift the material off the cut bed. And you'll see when we cut this center circle out, that turbulence will lift that part out of there. So I'll show you in the software where if you don't want that to happen and you want to save that little part in the middle, you need to add a tab to the cut. And that's very simple to do. I'll show you where we do it in the software. So the operating decibel level is about 74 decibels. We put it, for perspective, we put it like somewhere between a washing machine and a shop vac. But technically it's 74 decibels. So it's finished cutting that center circle out. Now it's moved on and it's cutting the outside shape. It will always cut internal features first. That's the way the software works. And you can see that inner circle there just got lifted out of place. It'll probably get flushed down the tank in a minute. It's not a problem. But if you didn't want that to happen, then you would have added a tab there. So Jill is asking how long the cut beds last, and that is around 50 hours, depending on the type of cutting that you're doing. 50 hours of cut time for the cut beds. The nozzles also will wear, so you've got three consumables. The cut beds, they run about 50 hours. The nozzles, you'll have to replace the nozzles after about 300 hours, depending again on the type of cutting you're doing. You can get longer life out of the nozzle if you don't mind having a slightly wider kerf. And then the abrasive, of course, you're using about 1/3 of a pound of abrasive a minute when it's cutting. So I will go ahead and share my screen while that's cutting and show you how the software works. So this is our website, our nice, lovely new website. And the first thing you do to create your WAM account. WAM is our CAM software. We very cleverly named it WAM. And you go to this login button and log in here, and it'll take you into your WAM account. The first time you do that, you'll need to create your account, enter your contact information, etc., and create your WAM account. And it'll ask for your serial number of the machine that you've purchased. That serial number is how you unlock the very last feature of the software, which is generating the G-code file. Everything else I'm about to show you, you could do right now without even purchasing a machine if you wanted to practice in the software, but you won't be able to generate the G-code files until you get a serial number to unlock it. So the first thing we do is we import a file. These are the files I'm looking for. So I'm going to bring this one in. It's a DXF file. The WAM software works with either DXF or SVG, just those two file types. So I just brought it in. There it is. I can grab it. I can position it anywhere I like on the cut bed, and that's where this grid pattern comes in on the cut bed. So if I know I've got my material positioned up in this top left corner, I can put my part there, and I can position it inside where my material is. I can add another one. I can make a duplicate right there if I wanted to make two. We can bring in one of the other parts here, the roof. So I need one roof. I need two fronts. Bring in the other part, and I need two sidewalls. So I'll add two sidewalls. So these are the 5 parts that make up my house. Yeah, front and the back, 2 sidewalls, and a roof. That's what we're cutting here today. Now, I'm not going to cut them all out in different materials. I'm going to cut it all out in one material, but just to show you how you can bring in multiple files as well as multiple parts. And then if I go to this button here in the top right, I can tell the WAM software I want to treat this as one cut file and cut them all out at once. So by selecting this button, I've selected all these parts, and now I'm going to treat it as one cut file, and I can move it around the cut bed as one cut file. So the next step is the scale and position. So this is a neat feature. When I'm nesting these parts, for example, I might want to turn these 90 degrees because I'm nesting it on a piece of material that I can get more utilization of my material that way by nesting them differently. I can, come on. I can scale the parts. So let's say I want to make one of these houses, and now I'm gonna do it again, but I want to make it 1.5 times size. I can make it 1.5, scale it by 1.5, and now I just made it 1.5 times bigger. I can use that scale function to scale the part. I can make the parts a specific width or height if that's what I'm shooting for, and it doesn't match the DXF file that I designed. So I'll put this back to 1 just for the demo purposes. And that's about the limit of the manipulation you can do to the actual part file in the WAM software. We've made it really simple and accessible. The next step is choosing the material profile. So the WAZER, well, now that I'm at this point, I'm going to pause and I'm going to start the next cut. So the next cut is the acrylic, the yellow acrylic. So I'm going to choose that particular file and get it started. So again, it's going to calibrate. Then it's going to come down to where it's going to start the cut. And it walks me through all these. Have you filled the abrasive? Have you turned everything on? Have you fastened the material? So you can see it's piercing. And when that splashing changes, that means it's pierced through. So that was it. It took a few seconds to pierce through that acrylic. All of these materials are 1/8 inch, by the way. So we'll go back to the screen share. So these material profiles are simply the speed that we're going to cut. The WAZER has one pressure, one flow rate, one abrasive feed rate. Always runs at the same pressure and feed rate and flow rate. So these, the only thing that changes is the speed, the length of time it pierces, and the speed of the cut. So if I go in, I can choose. WAZER has already loaded all these materials into so you'll have access to all of these in your accounts. Aluminum 6061 in all these imperial thicknesses, as well as metric thicknesses, steel in multiple thicknesses, more aluminum, stainless steel in multiple thicknesses, titanium, all of these materials already loaded, hundreds of them already, profiles already created, plastics and rubber. So we've got high density polyethylene in all these different thicknesses. Same with some urethanes, polycarbonate, silicones, already loaded, profiles already loaded. Ceramics, so there's glass in various thicknesses. There's ceramic tile, marble, etc. Now, but if you wanted to create your own material, if the material you want to cut wasn't in this list, you can simply add or edit a new one. So if you wanted to start from scratch, we have a material test program in the firmware that you run, and it simply just does a long pierce, and you measure how long does it take to pierce. You time that pierce, and then obviously stop the pierce and take note of that time. Then it'll cut some loops in the material at a differing speed, and you count how many loops did it go before it stopped piercing. You look that up on a chart, and that's how you get these numbers. So very simple to create a new material, but you can also just edit an existing one. If you wanted to choose an existing one, it gives you all the numbers. And if you happen to know that that material profile is very similar to the one I'm trying to cut, you can just simply edit these numbers, save that as a new profile, and that profile will then be available in your account. It won't be available in every account, it'll only be available in your account. So the difference in the profiles that you create are, you'll have this little head and shoulders symbol here. That's a custom material profile that someone created and added to this account. Any that have a W, those are the ones that WAZER created. So for this exercise, I'm going to cut this part out of 16 gauge aluminum, 63 thou thick aluminum. I'm going to cut all 5 of these pieces out. The next step in setting up the G-code is choosing the cut path. So let me zoom in a little on this one. Right now, we've got the offset of the kerf set to 22 thousandths. That represents half of our kerf. The width of the Waterjet cut, the kerf of the cut is 44 thousandths. So it's going to cut 22 thousandths on either side of my design line if I choose center line. I can go to outside, and it moves that cut to the outside of my design line. 100% of that kerf is now on the outside of my design line, except for internal features. The software is smart enough to know if it's an internal feature, I probably want the finished hole to be the size I've designed it. So I'm going to stay on the inside there instead of the outside. Another nice feature of this is I can actually change that offset by just a few thousandths, so I can sneak up on the dimension of a part. If I'm trying to make a part really precisely, a hole really precisely, I can cut one, measure it. It's 5 thou too small, it's 5 thou too large. I can make that change right here in the offset. So I can sneak up on the dimension of some features, which is pretty nice. This next step is setting the tabs. So these are the tabs that I was talking about. See that center circle there? That's the piece that got lifted up by the turbulence in the tank. If I had left this tab on it, that wouldn't have happened. So again, let me just pause because we've finished cutting the acrylic piece, and I will move on and cut the next piece. And the next piece is glass, 1/8 inch glass. There it goes to home again. So I'm going to cut, and it'll go to the first pierce point. So this is a different shape this time, but there goes piercing the glass. So what was that, like a second to pierce that 1/8 inch glass? Oh, you can't see it. There we go. Okay, there's a good question about the reusing the cut bed from Jill. You can reuse the cut bed as long as you can get screws to hold in it. So if you're cutting the same part on a regular basis, cut it in the same place, and then you're not cutting where your screws are. You're only cutting underneath the material. That doesn't affect anything at all. The life of your cut bed is really determined by the fact that I can't get screws in it anymore. The screws, I've cut it in so many places that there's nowhere for a screw to hold anymore. That cut bed is 4 inches thick, so you can cut multiple times in the same area. So no, you do not need 6 different spots on the cut bed. We'll go back to creating the G code. So this is automatic tab placement. The software has chosen where to put these tabs. I can override that and I can move them manually. I can position them anywhere I want. If I want to put it on a particular spot on the part that isn't critical, because I know I'm going to have to clean it up after, I can move them manually. I can change the count, I can add more, and I can change the width of those tabs also. So just for the sake of the demo, I'm going to go no tabs. The last step, second to last step, is cut. There are 3 speeds on the WAZER, coarse, medium, and fine, and that's all they are, is a slightly different speed setting. I think it's about 10% between those speeds. All 3 of these will cut your material. So let's look at this in a coarse setting. Those 5 pieces in 63 thou thick aluminum would take 24 minutes to cut, all 5 of those. On a medium setting, 27 minutes. And on a fine setting, 30 minutes and 50 seconds, so 31 minutes. So that's how we generate the G code files. I can now look at this and I can say, okay, I know it only needs 10 pounds of abrasive. It's only going to take 30 minutes. So I know I can start the cut, fill up the hopper and walk away, and it'll finish the cut. If it is more than an hour, I know that I need to come back and refill the hopper with abrasive, because the hopper will only hold 1 hour's worth of cutting. So the last and final step is this button here, generate job file. This is the only button that will not work for you until you have a serial number to unlock it. So generate job file. I should have given it a name. There it is, the G code. That's my G code file. So I just take that G code file and place it on my SD card or save it on my computer or a thumb drive or something for later use. But that's how we generate the G code files and create the G code files. Any questions about the software? We've tried to make it, as I said, as simple and accessible. So it doesn't have a ton of bells and whistles like a lot of CAD/CAM programs. We've tried to keep it as simple, straightforward, and accessible. That's our mission, is to make digital CNC waterjet cutting accessible and affordable to any workshop. Okay. So looks like this cut has finished. That what perfect timing, like we planned it. So once the cut has stopped, I can push the gantry out of the way, and we can take a look at our parts. So we've got one side there, 2 sides, and then the glass part, I believe, is the roof. So there's the glass part. So I'll just zoom in a little on one of the parts just to show you the cut. So that's a pretty clean circle cut there. And then the corners. I'll assemble it together in a second. So that's the acrylic. This is the high density polyethylene. So how would you do that without a water jet in that kind of time? You know, multiples, and then the glass. It does a phenomenal job on glass. So that's how we cut. And I remember I told you we cut the carbon fiber part and the aluminum part. We already just cut those out before the demo because we didn't want it to run too long. So let me show you. So I've got my aluminum part here, my aluminum part, and my carbon part. We'll see if I can assemble it, Chris. Oh, operator error. I put one wall on upside down. Chris didn't poke-yoke it for me. Another word for poke-yoke is idiot-proof it, right? And there's our little box with our roof that we just cut out. So the aluminum piece and the carbon piece would have added maybe about 10, 12 minutes, I think, to that whole time. So that's why we did them a little early. And obviously we just did it in multiple materials to show you the versatility. So that's basically the demonstration. I'd be happy to look for any questions now. Yes, only through cuts, Michael. No etching. It's designed for just through cutting. If you imagine the WAZER not pierced through, right? So if you've got a piece of material in here and you saw the splashing on top of the material before it pierced through, all of that energy, if you were etching, all of that energy would be coming back into the cavity and filling it up with abrasive, etc. So we don't recommend trying to etch with it. No, it's designed for cutting through. So the next question is on the abrasive. There are a couple of ways to do that. The G-code file, when you create your cuts, when you create your G-code file, right here, it says estimated abrasive use 10.17 pounds. So it shows you right there how much abrasive you're going to use. But there's even an easier way now with our new website. So if you go to the materials section on our website, not only do we have some fantastic information about all these different materials, We also have a cutting calculator where you can put in your material type, aluminum, 1/8 inch, length of cut, 50 inches, number of pierces, 1 pierce, hit the calculate button, and it tells me it's going to cut at 1.7 inches a minute. The pierce time is going to be 20 seconds. The job time, 29 minutes and 50 seconds. And it's going to use 9.9 pounds of abrasive. And then this cut cost, job cost, that includes the cost of your all your consumables, your cut beds and your nozzles, replacing your cut beds and your nozzles. So this is a nice feature. So you just take a look at your design files, estimate the length of the cut, and then how many times is the WAZER going to have to stop and restart a new pierce, and this will give you quite an accurate job time and abrasive usage. Or you can just use the WAM software the way I created the G-code file.
Tom, there's a question about taper. Would you want to respond to that? It's
Yep.
the last one. When Michael asked about angular deflection, as we call it, is taper. Do you want to?
Yeah. So yep. So we get some draft on the side of the part. So if I show you a thick part, I'll show you some 5/8 inch glass. So this is a piece of 5/8 inch glass, and you may be able to tell that this is not perpendicular, not 90 degrees. There is an angle on the sides. So the WAZER cuts with draft. So the cut, you can imagine the pierce as like a cone. It's wider at the top than it is at the exit. And that angle depends, the severity of that angle depends on the thickness of the material, right? So just the time it takes to pierce through, but also the density of the material. So the slower you cut, the less draft you're going to get. The faster you cut, the more draft you're going to have, because you're not giving the WAZER time to abrade the whole surface. But you will always have some, especially on thicker materials. It's barely going to be noticeable on an 1/8 of an inch, maybe 1 or 2 degrees. But then after an 1/8, you get like a degree about every 1/16 of an inch. And it's not something that you can completely avoid with a Waterjet cutter. You can minimize it by cutting really, really slow. So we set the speed of the cut using the software and the G-code, but you can override that with the buttons on the WAZER. So when it starts cutting, you hit the up arrow and it will speed up by 10%. If you hit the down arrow, it will slow down by 10%. So you can actually manipulate the speed of the cut right there in the manually on here. If you wanted to try and cut a piece with less draft, see if you slowed it right down, will that reduce the draft? If that's something that's important. What's an average maintenance cycle? So an average maintenance cycle. So every 300 hours, you got to change the oil in the pump at 300 hours of cutting time, and it keeps track of your cut time. That's the ongoing kind of mid to long-term maintenance. As far as regular maintenance is just keep it clean. So all of that used abrasive is going into the tank, right? You want to, if you allow that used abrasive to collect in the bottom of the tank for too long, then the low pressure circulation system that I showed you won't have enough power to lift that abrasive up and flush it into the collection buckets. So do that after every couple hours of cutting. You know, run the used abrasive collect, keep it clean, flush the used abrasive down into the tank and run that cycle. You know, we have a hose, you might have noticed in our connections here, and we just hose it down, run the used abrasive collect cycle. That's about it. Keep it clean. Keep your abrasive dry. It has to be dry to come up to the be sucked up into the mixing chamber. But maintenance is pretty straightforward, and it's really very well documented in our operating manual and online materials. All of the short, mid, and long-term maintenance. Yeah, like after a certain number of hours, you're going to want to check the tension in the belts, and you can adjust those. And then the pump box maintenance is the 300-hour oil change. But there's not a lot more than that. General price for the machine. Of course we do. That's what we in the sales trade call the buying signal, right? So let me share my screen again. So there are 3 options with the WAZER. There's the desktop version, which is without the stand, right? But it has, so this is the desktop. This is the shop page on our website, by the way. So you can look at the desktop, and the desktop comes with everything you see here. It comes with an extra cut bed, so you get 2 cut beds, 2 buckets of abrasive. So you get 110 pounds of abrasive to get you started, and then a bunch of little accessories and tools that come with it. So all of the machines come with this in the crate. The stand-up is $1,000 more, $10,999. And basically it's exactly the same accessories and everything, but it comes with the stand and the shelf. And then the final bundle is the starter bundle. The starter bundle consists of the stand-up model, a full pallet of 2,200 pounds, a metric ton of abrasive, 3 extra cut beds, so you get 5 cut beds total, and a spare nozzle for $11,999. So if you add all of this up individually, this is the best value. It's just really a matter of how much cutting are you going to be doing, because the 2 buckets of abrasive is 110 pounds. That represents about 6 hours of cutting time. So with the 2,200 pounds, you're getting over 100 hours of cutting time. So it just depends how much cutting you plan to do on which bundle you get.
Now, Tom, Jill had a question about idle time on the machine between uses. Like if it's safe to sit for long periods without being used.
Yeah. We recommend if it's going to be longer than 10 to 14 days, then you should drain it.
And then I had a question about the abrasive. Do you have, I mean, you said it was a standard abrasive used in the industry with water jets. Is that something you purchase from anywhere? I mean, or what is a specific type you guys sell?
Yeah, so there are a few brands that we've approved, but the one we use and sell is made by Barton. The company is Barton. They have distribution centers all over the country. When you buy abrasive from us, we actually have it drop shipped from your local Barton dealer. So if you want to buy it directly from them, you can buy it from them, or you want to buy it from us, you can buy it from us. It's the same price. We're not shipping abrasive all over the world, all over the country. So it's coming from the local distributor, the one local to you. And the brand is Barton, Barton. That's the one we use. That's what the machine was calibrated to use. But we have tested and approved a few other versions as well, or brands rather. So 80 mesh alluvial garnet. That's what everything is calibrated to work with.
No, I had one other question. Oh, actually, it looks like Jason beat me to the punch. Let's go with his first.
Do you provide any on-site setup or training, or is it pretty straightforward to plug and play? So we haven't found that that's necessary because we have excellent online materials, tutorials, the operating manual. We hear fantastic things. The operating manual it's online, but you also get a paper copy, and it's very, very well written, very easy to follow. So we haven't found that to be needed or necessary because it's so simple. But we do have a great support team. Again, you can check out the forums and everything on those guys. Phenomenal feedback and reports on the support team. And you can call in to the support number. You can just email support@wazer.com, or you can set up a Zoom meeting and they can do it over a demo for you. The manual is printed on waterproof paper, Dan. Thank you. Yeah.
I thought I had
Approx-
seen that.
So the machine empty is about 150 pounds. When it's full of water, it's about 400 pounds.
All right, so one other question from me, and
Yeah.
I suppose this is as close to a, hardball type of question, I guess, as
Okay.
I would have, but how does it compare to a bigger, scarier industrial model as far as water pressure and,
Yep.
specs and whatnot? I mean, obviously we all know that the big industrial ones cost a whole lot more, so we're not expecting it
Yep.
to be a perfect one-to-one. I'm just curious kind of what you're looking at in comparison to the big industrial things.
Mm-hmm. So it's all about hydraulic power, right? So we've got 4,000 PSI, maximum of 4,600 PSI at the nozzle, and we're feeding abrasive at a particular rate, which is about 1/3 of a pound a minute. That gives us, and a flow rate of 1/2 gallon a minute. That gives us a certain amount of hydraulic power, which means we can cut up to, realistically and practically, up to about 1/2 inch aluminum, 5/8 glass, 1/4 inch steel. The difference with, there's two ways that you go with a commercial water jet. They either go sky high on the pressure, right? So you can get water jets now that have over 100,000 PSI at the nozzle. They cut really fast. They get a lot of hydraulic power at the point of cutting. Or you increase the flow and the abrasive. So what we've done to get from I think it's a 1.5 horsepower motor, and the size pump we're using, and 110, 15 amps, right? So from the 1,700 watts or whatever it is that we're generating, using, and have to work with, to get the hydraulic power to cut up to 1/2 inch aluminum, we have a lot of flow and we have a lot of abrasive. With a commercial water jet, they've got, multiple horsepower pumps and 100,000 PSI, 60,000 PSI. But you have to look at the flow rate as well to calculate the actual hydraulic power. So it's not just a 1-for-1, because it depends on the flow rate and the abrasive feed rate as well. Does that answer your question, Michael? We're at 4,000. They're at, tens of thousands. They can cut a lot thicker. They will cut faster. But then again, you need 220, probably 3-phase in many cases.
And Tom, let me jump in also. I would add, Michael, to actually go even a little bit more, if you will, nitpicking on your question about this versus industrial water jets. This is an industrial water jet on a smaller scale. So it'll cut, like you saw, carbon fiber, metals, and so on. So that the difference is really, it'll do an industrial job. In fact, Tom and team have successfully sold it to NASA. Tesla just took their 3rd machine. Every branch of the armed services uses it. So it is a fully industrial level machine, and most of the automakers, from Honda, to Ford, also have got them. The difference is that this is a small machine, so that designers, engineers, prototypers, model makers can work on it without having to go to the 4x8 foot machine that that's in another building or that's in the factory. So it is an industrial grade machine, to take your questions. The difference is it is a smaller industrial grade machine that doesn't cut as thick, and it's got the 12x18 size bed as opposed to 8 foot by 4 foot and cutting 12 inches of material. So that's really the difference. Is the use case is for smaller jobs that you can do yourself rather than having to outsource or have a investment in a large size industrial machine.
Great answers. Thank you. I appreciate it.
It's all about the power.
Well, do we have any other questions before we wrap up?
Yeah, Michael, before we do wrap up, we may want to remind and share with your members.
Yep.
And Samantha, I'll need to follow up with you, that we'll be providing Samantha with some codes that if anybody is interested, Samantha will be able to provide you with a discount code to share when you call on into WAZER or have a session with Tom and his team for your own needs. That'll be good for $500 off on the machine. And Samantha, I know you and I traded notes on it. We'll get you a stock of codes that you can share with members, and there'll be a one-time use. So after it's used, it won't be usable a second time.
Yeah, so just get the code from Samantha, or and you can either use it directly online as a Shopify code, one-time use, or if you call in or email us and engage with the sales team, you can just tell us that you have the code and we'll honor it. It's not, you don't have to go online and use it if you want to do. And if any of you want like an individual demo, one-on-one, or you want any more information, please, reach out. It's info@wazer.com. Let us know that you were here on the with the Model Makers Association, and engage, and we'll answer any questions. We can do some sample cuts for you if you've got a particular material that you're worried about, or you want to see a particular quality of a cut on your specific piece of material or application. We'd be happy to do that for you, and engage with us that way.
And I would throw in a personal plug there, just from my perspective. We've been looking at one of these for a bit, and WAZER's been super responsive, and I've sent a box of samples of some specific materials that we work with to them, and they cut samples for me, turned them around real quick, got them back to me. So yeah, highly recommend on that regard.
Thank you, Michael. All right.
Well, I think, no, I'm not
Well, this
seeing
was
any more-
fun.
Yeah, I'm not seeing any more questions, so I guess we can go ahead and wrap it up then.
Yeah, if anybody wants to buy this little house, I'll put it up for sale. Or Chris, are you making the design files available free, Chris, or are you gonna charge to download them?
For the goodness of my heart, the file is free, but downloading it costs $1.
Said like a true model maker.
All right, so the last thing I wanted to throw in there is a definite thank you to these gentlemen for coming and presenting for us today.
Welcome.
Very much appreciate your time. It was an excellent, very in-depth demo.
Yeah.
And then finally, for the rest of the members who are still on the call, I just wanted to throw out, in 2 weeks, we'll be doing a Halloween-based meetup, more of a lighthearted thing. We'll basically just want to see what you're working on for Halloween. If you got any cool, model maker projects you got going on around your house or anything like that, some process photos or whatever would be great. If you're working on a really sweet costume for one of your kids or whatever. So that's in 2 weeks on Thursday, the 27th. So look out for the notification on that. And I want to thank you all very much for your time today and spending it with us. So I'll see you.
Thanks, everyone.
Thank you, Michael.
Thanks, everyone. Thanks, Michael.
Everyone have a great afternoon.